Okay, so in this video, I'm going to teach you how to determine the nature of the roots of a quadratic equation ax squared plus bx plus c equal to 0. Okay, so what do we mean by the nature of the roots of a quadratic equation ax squared plus bx plus c equal to 0? Let me just give you a conceptual background of this. If a function is y equals ax squared plus bx plus c, which is a function whose graph is a parabola, there can just be three possible scenarios in which how we relate the parabola to the x-axis. Although we know that a parabola can open up or down in relation to the x-axis, it's either the graph is not crossing or touching the x-axis, so maybe if it's opening upwards it should be like this, or if it's opening downward, so it is like this. So this means the parabola is not touching or crossing the x-axis. So that's the first case. The second case would be the parabola will be touching the x-axis at one point. So we can see that as a, let's say, we could place it anywhere. Just consider the condition that it will only touch the x-axis at one point. So it's not crossing it, so it will just be touching the x-axis. So if the graph is opening downwards, so we could imagine a parabola in this manner. And then the third case, so that would be, so that's letter C. Now the parabola could be crossing the x-axis this way. Now I can place it anywhere. I can place it here on this side. We just want to consider the number of points where it will cross the x-axis. It will cross 2 points. Or again, if it's opening in the opposite direction, so the graph will behave this way. But again, it will be crossing or intersecting the x-axis at 2 points. So this is at 2 points. The second one is just on 1 point. Okay, so what is the connection of this to the nature of the roots? The nature of the roots is basically just a description of these three scenarios. Okay, the first one, so the letter A, if the graph is not touching or crossing the x-axis, so that means the quadratic equation, so for ax squared plus bx plus c equal to 0, and if this is coming from y equals ax squared plus bx plus c, if it's not touching the x-axis, that means there are no real roots. So that's the nature of the roots. So you have no roots, you have no real roots, so yeah, you cannot cross or touch the x-axis. The second one, you have one real root, and then the third one, since it crosses the x-axis at 2 points, you have two real roots, and these roots are distinct. Okay, so they're different. Okay, so like this is one root, and then the other root will come from this point. Okay, two real and distinct roots. Now, common to problems involving quadratic equation will be determining the nature of the roots. Okay, so when we determine the nature of the roots, we are not really looking for the roots. We just want to identify if we have no real roots, one real root, or two real roots. And you might say, we cannot just always sketch the graph of the given function. Okay, so there must be a way, or we should have a different way in finding the nature of the roots. Okay, so in this video, so I'll focus on that. And here's the idea. For any ax squared plus bx plus c equal to 0, so provided that the quadratic equation follows this form, then when you compute for b squared minus 4ac, we call this the discriminant, then its value will determine the nature of the roots, and it will fall under three cases. So first case, when b squared minus 4ac is a positive number, meaning greater than 0, the nature of the roots is that there are two real roots and they are distinct, or two real and distinct roots. The second case, when b squared minus 4ac is less than 0, then that means there is no real roots. In the third case, now what if that b squared minus 4ac is exactly 0? We say there's one real root. Okay, so how do we apply this idea? Let's select let's get an example. Okay, so suppose we have, so let's say example. Suppose we have y, or not y, let's make this straight to a quadratic equation. Let's say 2x squared plus 3x plus 5 is equal to 0. So we can solve for the values of x, and then we could say there are no real roots, or there's just one. But since we know that the value b squared minus 4ac will determine the root, or the nature of the roots, then we'll just apply it. Okay, so b in this case, so our a is 2, our b is 3, and c is 5. So b squared minus 4ac will be 3 squared minus 4 times 2 and then times 5. So this will be 9 minus 4 times 2 is 8 times 5, 40. And this is negative 31. So negative 31 is a negative number, so it is less than 0. So less than 0 means there are no real roots. So when you graph y equals 2x squared plus 3x plus 5, the graph will not touch the x-axis. It will not even cross the x-axis. Okay, so that's how you apply the discriminant, the b squared minus 4ac. Okay, and then let's get another one. So let's say, so let's have another example. Example 2. Let's say x squared minus 4x minus 12 is equal to 0. So when we apply, so just apply the b squared minus 4ac. So we have b squared minus 4ac. So get the values of a, b, and c. So b is negative 4 squared minus 4 times a is 1 and c is negative 12. So this is 16 minus 4 minus 12. This is multiplication, so that's positive 48. Okay, so this is equal to 64, which is a positive number. And when it is a positive number, according to the rule, when the b squared minus 4ac is greater than 0, then we say that there are two real and distinct, meaning they're different roots. Okay, so again, keep in mind that we're not looking for the roots, but we are looking, or we are determining the nature of the roots. Okay, so we don't know really what are these two real and distinct roots, but we know that there are two real and distinct roots. Okay, then let's just have one more example. So let's say, so example, this is now number 3. X squared minus 2x plus 1 is equal to 0. So when I apply b squared minus 4ac, so b squared minus 4ac, the determinant, so b is negative 2, and then you square, minus 4 times a is 1, times c is 1. Okay, so make sure you know how to find or identify a, b, and c. So this is 4 minus 4 equal to 0. And again, according to the rule, when it is equal to 0, so that's our third. Okay, so we say that there's only one real root. Okay, so that's how you determine the nature of the roots. It's just one real root. Now, if you will be factoring this, just to show you, this will be x minus 1 times x minus 1 equal to 0. And you would say x equals 1 and x equals 1. In some books, they will identify this as two real but the same roots. Okay? So some will say there are two, but actually they're the same. So just to generalize that, we can just say that it's just one real root, because basically the two numbers are the same. Okay? So let's summarize what we have here. So again, the rule in determining the nature of the roots is that when you look for b squared minus 4ac, what we call the discriminant, if the value is greater than 0, a positive number, we say two real and distinct roots. When b squared minus 4ac is less than 0, there are no real roots, that's negative discriminant, and for b squared minus 4ac equal to 0, there's just one real root. Okay, I even showed you a conceptual background of that using the graphs a while ago, so from here. So I hope you also understand the connection of the concept to that of the graphs of the parabola y equals ax squared plus bx plus c. So just one important note, when you apply b squared minus 4ac, when you determine the nature of the roots, make sure that the quadratic equation follows this form, and that it's ax squared plus bx plus c, and the other side is equal to 0. Okay, so that's it.